Welcome back to the deep dive. We're diving into something a lot of you have been asking about. Backdoor attacks on large language models. Those AI systems like ChatGPT, or Google Gemini, they're everywhere these days.
Seems like it, yeah.
Writing code, analyzing financial things,
Oh, absolutely, yeah.
even in legal research, I've heard.
Yeah,
So LLMs are getting more and more woven into our lives.
definitely. Which makes it more and more important to really grasp how vulnerable they can be.
And that's where these backdoor attacks come in. I get that they're bad news, but I gotta admit, the whole thing just sounds so complicated.
Yeah,
Like,
yeah.
attacking an AI, how does that even work?
It's a good question. It's actually maybe not as complex as it sounds. Think of LLMs like, I don't know, super intricate machines.
Okay, yeah.
Built to process language, spit it back out.
Mhm.
Like any machine, they can have flaws, weak points. And that's what these backdoor attacks zero in on.
So it's like finding a secret way to mess with the AI's insides.
Exactly. Yeah. Like picture this. An attacker slips a secret code word in while the AI is learning. Later, when the AI sees that word, it goes haywire.
Okay, so it's working fine, giving helpful answers, then bam, it starts, what, lying?
Could be, yeah.
Giving away secrets, maybe?
Possibly.
All because of one specific word.
A phrase even.
That is kind of freaky. And you said these attacks can happen at different stages of the LLM's, life?
Life cycle, yeah.
So it's not just vulnerable while it's learning?
Nope. There are ways to get at them even after they're out in the world being used for real.
Whoa, okay, hold on. Break that down a little. You mentioned different stages. What are those exactly?
Sure. Based on this research, we can categorize them into 3 phases. You've got pre-training, fine-tuning, and then inference.
Right, so pre-training is like the AI's basic education. Gobble up tons of data, learn language, right?
Right. The foundation of its knowledge, you could say.
Yeah.
And attackers can target this phase with techniques like gradient-based trigger optimization.
Whoa, that sounds intense. Gradient-based trigger, what was it again?
Optimization. Think of it like, imagine them fine-tuning a question to sort of hijack the AI. They tweak the data it learns from just right to create a trigger phrase that, when the AI sees it, forces it to give the wrong info.
So even if someone asks a normal question, it's like, rigged.
You got it.
Okay.
Like a time bomb just waiting for the right words.
Oh, and it's not just messing with the data, right? You mentioned something else, knowledge.
Distillation.
Yeah, that. What's that about?
So picture this. They train a smaller model, a spy model, if you will, with a backdoor already built in. Then they transfer what that spy model knows to a bigger, stronger model.
So it's like sneaking in a saboteur.
Pretty much.
Yeah.
Creates this vulnerability that's really hard to spot.
Sneaky. It seems like it'd be almost impossible to catch.
Could be very tricky, yeah. That's why understanding how these attacks work is so important. But let's move on to the next phase, fine-tuning.
Okay, so fine-tuning is like specialized training, right? It's already got the basics. Now it's learning to do specific things. Translate languages, maybe write different kinds of creative stuff.
Exactly. And, like pre-training, this phase has its own vulnerabilities too. Parameter-efficient fine-tuning attacks, for example.
Parameter what now?
Parameter-efficient fine-tuning. Bit of a mouthful, I know. Think of it like, imagine you've got this huge language model, right? And you want to teach it something new without retraining the whole thing from scratch.
Yeah.
There are shortcuts for that, like LoRaWA stands for low-rank adaptation. But here's the kicker. Attackers have figured out how to use those shortcuts to their advantage.
Oh, no. So even when developers try to be efficient, it can backfire.
Yep. They slip those backdoors in while the model's learning new tricks.
That is, it's frustrating,
It is. And it's not just those shortcuts either. They're also instruction tuning backdoor attacks.
Okay, now that one sounds almost straightforward, like giving it bad instructions.
It's about targeting the very process of teaching it to follow instructions. They can twist the data it learns from, so even harmless commands can trigger bad behavior.
It's like training it to respond to a secret knock or something.
Good way to put it. And it gets even more complex when you consider federated learning.
Federated learning.
Yeah, it's where lots of devices work together to train a model without sharing their data directly.
So it's like a team effort.
Kind of. But attackers can find ways to poison the whole process.
So it's not just one model they're attacking, it's the whole network.
Exactly. And that brings us to the last stage, inference. This is where things get really tricky.
Inference, that's when it's, what, all trained up and out in the world?
Right. You'd think once it's trained, it's safe. But that's not true at all. There are ways to target these models even then. without ever touching their code.
Wait, how? If they can't mess with the training or how it works, what can they do?
That is what we'll dig into in the next part of our deep dive. We'll be looking at how they use things like instruction backdoor attacks and knowledge poisoning to manipulate LLMs even after they're fully trained.
Okay, I'm officially hooked. This is starting to feel like a spy movie or something. We'll be back in a bit to explore those inference phase attacks. Don't go anywhere.
It's a wild world out there. We'll shed some light on it and what we can do to protect ourselves when we're back.
Okay, so back to those inference attacks. You're telling me people can mess with these LLMs even when they're already out there being used. It's kind of unsettling to think an AI I'm chatting with could be, like, secretly compromised.
Yeah, I get it. It is a little unnerving, but researchers are on it, trying to figure out how to protect against these things.
That's good. But still, how does it even work? If they can't mess with the model directly, how do they slip in their instructions?
Well, one way is through what we call instruction backdoor attacks. Basically, it's like hiding a trigger phrase that'll activate the back door.
So, like those code words we talked about, but instead of being in the training data, they're what? In the questions we ask Kay the AI.
Exactly. Imagine you're on a customer service chatbot. An attacker could craft a seemingly harmless question with their hidden phrase tucked in. Suddenly, the AI might start saying totally inappropriate things.
Oh, yikes. Or giving away private info.
Could happen, yeah. Or even, like, redirecting you to a sketchy website.
So even just talking to these LLMs can be dangerous.
In a way, yeah. It's not just individual questions either. There's also knowledge poisoning, where they go after the AI's knowledge base.
Knowledge poisoning, so they're like messing with the information the AI uses to answer questions.
That's it. Think of it like, I don't know, subtly changing Wikipedia entries to include false info.
Oh, wow.
An LLM that uses Wikipedia for its knowledge would then start giving wrong or biased answers without even realizing it.
So it's not just about attacking the AI directly, but like contaminating its environment.
You got it. That's definitely a harder nut to crack. But researchers are working on defenses. Remember we talked about pre-training defenses?
Yeah, like building a strong foundation from the start.
Right. But there are also post-training defenses, focused on protecting the model once it's already out there.
Makes sense. So pre-training is like laying the groundwork. Post-training is more like adding security measures to a building.
Good analogy. One common post-training defense is input detection. Think of it like a security guard checking everyone at the entrance. In this case, the guard is an algorithm that analyzes the questions or prompts given to the AI, looking for anything fishy.
So they're checking for those hidden trigger phrases or anything else that seems off.
Exactly. There are techniques like onion and strip vita that are designed to spot these malicious inputs. They look for anything unusual, like weird word combinations or nonsensical grammar.
Like a lie detector test, but for language. I like it. But what about knowledge poisoning? How do you protect against bad info that's already in the AI's knowledge base?
That one's trickier. We need something more like model inspection, where engineers analyze the AI's inner workings, looking for signs of tampering or vulnerabilities.
Whoa, so it's like performing surgery on AI's brain.
Kind of, yeah. Techniques like neural cleanse and deep inspect use fancy algorithms to examine the AI's parameters, how it makes decisions, and look for anything out of place.
This is all so complex, but it sounds like a lot of effort's going into building these defenses. The question is, are they working? Can we really stay ahead of the attackers who seem to be constantly coming up with new tricks?
$1 million question, right?
Mm-hmm.
Truth is, it's an arms race. As soon as researchers develop a new defense, attackers try to find ways around it.
Always one step ahead.
It can feel that way, yeah.
Yeah.
One challenge is that many defenses are built for specific attacks. They might work against simpler ones, but struggle with more sophisticated or adaptable ones.
So it's like having a lock that only works against certain keys.
Exactly. Plus, some defenses can be really resource-intensive or need specialized experts to set up. That makes them pretty much impossible for smaller companies or individuals to use.
So you'd need a whole team of cybersecurity pros just to use a simple chatbot?
It can feel that way sometimes. But the good news is there are also simpler defenses that can be pretty effective. Being careful about where you get your training data, making sure it's clean, that kind of thing.
Back to basics, huh?
Yeah. And of course, always be skeptical of what AI tells you. Double-check info against sources you trust.
So even in the age of AI, good old-fashioned critical thinking still matters.
More than ever.
Yeah.
And remember, it's not all about technical solutions either. We need to think about the ethical implications of this tech too, and develop guidelines for responsible use.
Right. Because even with perfect defenses, we still need to be thinking about the potential consequences if things do go wrong.
Absolutely. As LLMs become more integrated into our lives, it's not just about protecting the tech itself, but making sure it's used for good.
Makes you wonder, what are the most promising defenses? I mean, you've painted a picture where attackers are always a step ahead. Is there anything that makes you optimistic about the future of LLM security? That is the question, isn't it? What gives you hope?
Well, there are some really exciting things happening. One area I'm particularly interested in is more robust defenses, like defenses that can handle a wider range of attacks.
So instead of a different lock for every key, you're saying we need a master key.
Exactly. You see, a lot of the defenses we have now are very specific. They work against one type of backdoor attack, but not others. Researchers are trying to develop techniques that can spot and stop a much broader range of attacks, no matter how they're done.
Okay, so how would that work?
Well, it often involves looking at the AI's behavior on a much deeper level, spotting tiny anomalies that might signal something's wrong.
I see. So it's like having a security system that doesn't just check the doors, but also watches for any suspicious activity inside the building.
Perfect analogy. But what about those resource-heavy defenses, the ones that need tons of computing power and expertise? Are those getting any easier to use?
Yeah, that's what I was wondering. Can smaller companies or individuals even USC those?
That's another big focus of research right now, making these defenses more efficient and user-friendly. Things like creating open-source tools that anyone can use to analyze their models.
Oh, interesting. So it's like giving everyone a basic security toolkit for their AI.
You got it. There's a real push to democratize AI security, make it accessible to everyone, not just the big players. And there's one more thing I think has huge EE potential, using AI itself to defend against these attacks.
Wait, using AI to fight AI, is that even possible?
Oh, it's not just possible, it's already happening. Think about it. AI is great at spotting patterns and anomalies. It could be a powerful tool for detecting backdoor attacks.
So, like setting a thief to catch a thief.
Uh-huh, kind of. It's still early days, but the research is very promising. It's a little mind-blowing, I know, but it makes sense when you think about it. AI is a powerful tool, and like any tool, can be used for good or bad.
Right. It all comes down to how we use it. So you're saying the future of AI security might actually depend on AI itself.
It very well could. And that's both exciting and a bit daunting, isn't it? But I think that's the thing about AI in general. It's pushing the boundaries of what we know, what we thought was possible.
You've given us a lot to think about today, but I have to say I'm feeling more optimistic now than I was at the beginning. It seems like there are some brilliant people out there working on solutions. We're not just sitting ducks, are we?
Not at all. And it's not just about the researchers and developers either. We all have a role to play in AI security
What do you mean?
by staying informed, asking questions, and just being generally aware of the risks. We can all contribute to a safer, more trustworthy AI-powered future.
So it's a team effort. Everyone from the experts building defenses to the everyday users need to be involved.
Exactly. The future of AI is in our hands. It's up to all of us to shape it, to make sure it's a future we can trust.
And that's a future worth fighting for. Thank you so much for joining us on this deep dive into the world of backdoor attacks and AI security. It's been an incredible conversation.
The pleasure was all mine. It's been a great discussion and hopefully a good reminder that even with powerful technologies like AI, there are always challenges to overcome.
And to all our listeners out there, we encourage you to keep learning, keep asking questions. The more we understand these complex systems, the better equipped we'll be to navigate the exciting and sometimes challenging world of artificial intelligence. Until next time, keep diving and keep learning.